Now we'll look at the problems in the 8th assignment. This is a non-inverting amplifier using an op-amp. We already know that the gain of this V0 by Vi is K, which is 4. Okay, if this is R and this is K minus 1 R, then the gain would be K divided by 1 plus K by A0. Okay, and with the values given to us, it's 4 divided by 1 plus 4 by 396, okay, which gives you 3.96. So it's just to see the effect of finite gain of the op-amp on the gain of the closed loop amplifier. Okay. The next question, you're supposed to find which of these terminals A and B should be negative for negative feedback. Okay. So let me assume that A is positive and B is negative. That is, the difference input of the op-amp should be that way, Vd. Okay. Now what is the algorithm here? I have to get rid of the op-amp, that is, I remove it and I connect a voltage source here which represents the output of the op-amp. Okay. Basically I am trying to find the feedback around the op-amp. Okay, so the op-amp itself is removed, and if V out is like that, and I assume that A is positive and B is negative, and find out what this turns out to be. Okay, so if I do this, if this is V out from voltage divider formula, I know that this will be V out times 2 divided by 8 or V out divided by 4, and this voltage will be V out times 1 divided by 5 or V out by 5. Okay, so this Vd will be V out by 4 minus V out by 5, which will be V out by 20. So if the op-amp signs were like this, A positive and B negative, then we see that the input voltage of the op-amp is a positive ratio 1 by 20 times the output of the op-amp. So this means positive feedback. So these are not the signs. It should really have been that way. Okay. So B is the positive terminal and A is the negative terminal. You are asked for the negative terminal of the op-amp, so the answer is A. Okay. In this case, what happens is there is feedback to both terminals of the op-amp, but there is more feedback to A and less feedback to B. So A has to be negative, so that overall there is negative feedback. Now in this case, assuming that the op-amps are ideal, you are supposed to find the output voltage V0. Okay. How do you do that? If the op-amps are ideal, these two are virtually shorted, so this voltage is V1. Okay, and these two are virtually shorted, so this voltage is V2. Okay, and then you write Kirchhoff's laws at the op-amp inputs. So first of all, this is V0, and let me call this Vx. Okay, we know that the same current flows into this and into that one. That is, some current flows here and it has to flow that way. Okay, then V0 minus V2 divided by 2 kilo ohm should be equal to V2 minus Vx divided by 8 kilo ohms. Okay. So what do we get here? Vx will be minus 4 times V0, okay, plus 5 times V2. You can simplify this expression to give you that thing. Okay. Then we also know that this V1, any current from here simply goes into the other resistor. So V1 is Vx divided by 2. Okay. So V1 is Vx divided by 2, which is minus 2 times V0 plus 2.5 times V2. What do I want? I want the expression for V0. So if I take it to the left side, I get V0 to be minus 0.5 times V1 plus 1.25 times V2. Okay. So alpha, which is the coefficient of V1, is minus 0.5. Beta, which is the coefficient of V2, is 1.25. Okay. So the second question is about alpha. So this is minus 0.5, this is 1.25. Okay. And the op-amp signs are not really given in this schematic, so you're supposed to find out the signs so that the op-amps are in negative feedback. Okay. How do I do that? When I have two op-amps, I'll first assume that one of the op-amps has its sign correctly assigned so that it behaves like a virtual short, and then find the signs for the other op-amp. Okay. So let me assume that OPA2, it is correct. Whatever it is, it's correct, and I have to find the signs for OPA1. And I'll redraw the circuit with V1 reduced to 0 and V2 also reduced to 0. Okay, A, B, and this is ideal. So that means that this is also at 0 volts. The algorithm is the same as always. I remove this op amp and replace it with some test voltage Vtest. What do I get? Because this is a virtual short, you will see that the current here is Vtest by 2 kilo ohms, and that goes into the 8 kilo ohm resistor which is in feedback. So this voltage is minus Vtest times 4, and this voltage is half of that, so that is minus Vtest times 2. Okay, whereas this is 0. Now I want the op amp to be in negative feedback, that is the difference input of the op amp should be minus something times the output voltage of the op amp. So you can clearly see that if the op amp signs are this way, the difference voltage Vd would be minus 2 times Vtest, which satisfies the condition for negative feedback. Okay, so the negative terminal of OPA1 is A, so that should be minus. Okay, now that that is already known, we can find the signs for OPA2. Again, I have deactivated the independent sources because they play no role. So this is A and B. We have to find which one is negative. Okay, there is another resistor here. So again, I remove this op amp and apply a test voltage where its output was. What do I get? First of all, here at this point I'll get Vtest divided by 2, and here I'll get some positive number. Let me say the gain of this op amp is A0. It's A0 times Vtest divided by 2. It's some positive number, that's what we want. Okay, and this is the input of the op amp. The other input is at 0 volts, and this voltage, what is that? That will be related to this and that one. Okay, it will be weighted summation of this voltage and that voltage. And again, if you calculate it, you will see that it will be, let me call this Vx. Vx will be Vtest times 2 by 10. That's the contribution directly from here, and the contribution from there would be plus A0 by 2 times Vtest times 8 by 10. You can calculate this, but the important thing is to recognize that this is some positive number times Vtest. Okay, so if it's a positive number times Vtest, then it's clearly this way, that is the sign of the op amp has to be this way. So then Vd will be equal to minus Vx, which is negative of this whole thing. So it will be a negative number times Vtest. Okay, so the sign of OPA2 must be minus and plus, and even for OPA2 terminal A is the negative terminal. Okay. So this is A and this is A. And this problem, there is an ideal op amp but with some supply voltages. So that means that it behaves ideally as long as the output doesn't exceed these supplies. Okay, either doesn't go above 12 volts or doesn't go below minus 12 volts. If you calculate assuming an ideal op amp and if the output comes out to be above 12 volts, it means that it will be saturated to 12. Similarly on the negative side. Okay. The input is 1 volt plus Vp cos omega t, and this is an inverting amplifier, so the output will be minus 3 volts minus 3 Vp cos omega t. Okay. And what do we want? We want this to lie between minus 12. I'll write minus 3 Vp because the maximum value of this is what matters. Okay. So it's either minus 3 Vp or plus 3 Vp. And on the other side I'll have 12. Okay. So this can be either plus or minus. Okay. Or graphically you can see that, let's say plus 12 is there, minus 12 is there, the output is centered around minus 3 volts, and it will look like that. And pictorially you see that this is the worst case when this sign is negative. Okay. Also this point will reach minus 12 volts. It will reach plus 12 volts for a much higher amplitude because the sine wave is skewed to the negative side at the output. Okay. So I'll just write that minus 12 equals minus 3 volts minus 3 Vp. Okay. So that's the case when the negative peak just reaches minus 12 volts. Okay. So that tells you that 3 Vp equals 9 volts or Vp equals 3 volts. That's the answer. Okay. If the input is 3 volts, then essentially what happens is that the maximum value of this becomes 4 volts, and that multiplied by the gain of the circuit reaches minus 12 volts. Okay. The next question, you are asked about the currents that is drawn from the op amp, and you are told that basically the current drawn from the positive supply is whatever current is flowing in this direction plus some fixed value, whereas the current pushed out into the negative supply is whatever current flows into the op amp output plus the fixed value. Okay. So when Vi equals 0, the output voltage is 0. Okay. So no current is flowing this way. This is 0. But you are told that Ip and Im are 3 milliamperes. So the fixed current of 3 milliamperes flows through the op amp. So that, let me call that I0. Okay. Now Vi is pi times cos omega t. So the output voltage here, this is a gain of 2, right? We have 100 ohms and 100 ohms. So the output voltage here will be 2 pi cos omega t. And the current that is sourced from the supply will be 2 pi cos omega t divided by 200 ohms over here plus 2 pi cos omega t by 50 ohms because of the load. Okay. And what do we get? The result is 2 pi cos omega t by 40 ohms. Now that is the output current, and that looks like that. Okay. The amplitude is 2 pi divided by 40, and this axis is in amperes. And out of this we know that the positive part contributes to Ip. Okay, Ip will be average of this positive part plus I naught, which is 3 milliamps, and Im, the negative part will contribute to Im, so the negative current is that much, so the average of this plus I naught will be Im, and average of this red and green stuff is exactly the same because the sine wave is symmetrical. Okay, and how much is that average? That will be equal to 1 over pi times the amplitude. Okay, so the average is 1 over pi times 2 pi by 40 amperes, or 1 by 20 amperes, or 50 milliamperes. Okay, to this we have to add the fixed part, which is 3 milliamps. So the average current drawn from the supplies, so average value of IP, which is the same as the average value of Im, will be 53 milliamperes. Okay, and the last question, you are asked to determine the power delivered by the 3 volt source. Okay, this is quite easy. You should first recognize that this is a non-inverting amplifier. Okay, it is driven by 3 volts. So this voltage has to be 3 times the gain of this, which is 5, which is 15 volts. Even if you didn't recognize it as a non-inverting amplifier, the op amp is a negative feedback. By using virtual short, you should come to this result. Then the current flowing from 3 volts is 3 volts divided by 3 kilo ohm, which is 1 milliamp, and then there is a current this way, that is 15 minus 3, so the voltage here is 12 volts divided by 8 kilo ohms, so that is 1.5 milliamps in that direction, and nothing goes into the op amp. So the current through 3 volt source is actually 0.5 milliamp in that direction. Okay, now the voltage this way is 3 volts and current going in is 0.5 milliamps, so the total power is 1.5 milliwatts dissipated in the 3 volt source. You are asked for the power delivered, so that is minus 1.5 milliwatts. Okay, so that brings us to the end of the 8th assignment.